From the outside, the building looks abandoned. No lights glowing through the windows at night, no line of workers walking through the gates before sunrise, no parking lot packed with cars waiting for a shift change. Step inside, though, and the place never stops moving. Robotic arms swing from station to station with a kind of timing no human crew could hold for more than an hour straight. Cameras inspect finished parts in under a second. Driverless carts haul materials across the floor. And in entire sections of the building, the lights are switched off completely because nothing in there has eyes that need them. This is the Midea Smart Manufacturing Complex, built in Shunda, Guangdong Province, for somewhere around $1.2 billion. And here's the thing, it's not even the strangest one. It's just the one with the biggest price tag attached to its name. China didn't build this because it wanted to look futuristic. It was built because the math stopped working. For most of the last 40 years, China's pitch to the world was simple. We'll make it cheaper than anyone else can. And it worked. Spectacularly. Factories spread across Guangdong and Zhejiang and Jiangsu. Cities grew up around them practically overnight. And Made in China ended up stamped on more or less everything in your house. But cheap labor doesn't stay cheap forever. Between 2005 and 2016, average manufacturing wages in China roughly tripled, going from about $1.50 an hour to $3.60. That's the entire foundation of the country's manufacturing advantage starting to crack, in real time, while the rest of the world was still calling China the low-cost option. So, on May 19, 2015, the State Council put out a document called Made in China 2025. Most people outside the country barely noticed at the time. The targets inside looked, frankly, unrealistic. Manufacturers were supposed to hit 150 industrial robots for every 10,000 workers by 2020. In 2015, the actual number was 36. Hitting that target meant quadrupling robot density in 5 years flat, and plenty of Western economists publicly called it overambitious, maybe even impossible. By 2022, China was sitting at 392 robots per 10,000 workers, more than double what the plan had even asked for. And it didn't stop there. By 2024, China had crossed 2 million industrial robots installed nationwide, accounting for 54% of total global demand in a single year, according to the International Federation of Robotics. In 2022 alone, the country installed 290,367 robots, more than every other country on Earth combined. Picture handing a fully working industrial robot to every single employed person in the city of Pittsburgh. In 1 year. That's roughly the scale being talked about, and it's happening basically every year now, not just once. But the robot count was never the real headline. Buried in that 2015 plan was something more important, an instruction to stop buying robots from other countries and start building them domestically. At the time, China was the biggest customer in the world for a German company called Kuka, founded in Augsburg back in 1898, generally ranked among the top 3 industrial robotics makers anywhere on the planet. In 2016, a Chinese appliance company, Midea, the same one that makes your air conditioner, bought Kuka outright for 4.5 billion euros in cash. Sit with that for a second. A company best known for rice cookers and AC units had just bought one of the most advanced robotics manufacturers in the world. The Wall Street Journal called it a head-scratcher. Bloomberg and Reuters covered the deal with open skepticism because on paper, it genuinely didn't make sense. 7 years later, it made all the sense in the world. By 2023, Chinese-built robots from domestic firms like Eston, Xiaomi, and Innovance had grabbed roughly 36% of China's own robotics market. Before the Kuka deal, that figure sat under 10%. The acquisition didn't just hand China a robotics company, it handed them 2 decades of hard-won engineering knowledge in one signature. You can see exactly what this looks like on the ground. Before automation, the Changying Precision Technology plant in Dongguan ran with around 650 workers on the floor. After the robots moved in, that number dropped to 60, and those 60 people don't assemble anything with their hands anymore. They sit at screens and keep the systems running. Output roughly tripled. And the defect rate, the number that actually decides who wins a manufacturing contract, fell to 0.01%. A typical human-run facility of comparable size runs somewhere between 1.5% and 3% defects. At a scale of millions of units a year, that gap isn't a rounding error. It's the difference between winning the contract and losing it to someone faster. Walk into one of these plants at night, and the first thing that gets you isn't the dark. It's the sound, but no warning beeps and no safety chimes when something heavy is rounding a corner. A reporter from MIT Technology Review, who toured one of these facilities, described it almost exactly that way. The unsettling part wasn't the darkness itself. It was the machines moving past you without any sign they knew you were standing there. They don't slow down for a person in the wrong spot. They were never built to expect one in the first place. Inside the Midea complex, raw blocks of metal go in one end of the machining line and come out the other as finished. Polished parts no human hand has ever touched. The assembly stage works at tolerances measured in microns, a millionth of a meter, a level of precision where even a steady, well-trained human hand introduces too much shake. Every single part gets scanned in 3 dimensions before it's allowed to move anywhere else on the line. What keeps it all from falling apart is something most coverage skips entirely. Every robot in the building runs its own onboard computer, so the whole floor doesn't depend on one central server staying online. That solved an old problem. A network hiccup used to mean the whole line shut down, but it created a brand new one nobody planned for. When dozens of machines are all making their own routing decisions at the same time in a tight space, they start running into each other, sometimes literally, in ways the original programmers never coded for. Engineers at Changying spent over a year just watching what the robots actually did and writing rules afterward to stop them colliding. The factory more or less taught itself how to run. By running, Xiaomi took the idea even further. Their facility in Beijing, 81,000 square meters, roughly the size of 11 football fields, runs 11 separate production lines, with 100% of the key processes fully automated. Every single piece of software controlling that factory was built in-house. No foreign licensing involved. CEO Lei Jun described the system as one where the machines think, adapt, and optimize on their own, which is a strange sentence until you watch the output number. One finished smartphone every second, around the clock. 10 million units a year, with close to 0 human hands on the floor. It's not just phones and appliances either. Foxconn, the company behind most of the world's iPhones, replaced 60,000 workers with robots at a single facility in Kunshan back in 2016, and has since pushed to automate 30% of its entire global operation. BYD, which recently overtook Tesla in worldwide EV sales, runs heavily automated plants in Shenzhen and Xi'an where robots handle welding, painting, and battery assembly with barely any human oversight. And CATL, the company supplying more EV batteries than anyone else on the planet, has been scaling robotic production across its factories at a pace most competitors simply can't match. Now put all of that next to Germany, because the contrast is the whole story. Volkswagen converted its Zwickau plant to full EV production starting in 2018, opened it in 2019, and spent around 1.2 billion euros, doing it basically the same price tag as Midea's complex. Workers on that floor today are roughly 8,000, while workers on Dongguan's floor are 60. Same investment range, same category of facility, but wildly different headcount. And that gap has nothing to do with who builds better robots. Germany builds excellent robots. Germany built Kuka, for that matter, before it got sold off to the company that makes your washing machine. The real difference showed up after the factory's design, and the money's already sitting there ready to go. In 2018, a mid-sized auto parts manufacturer in Baden-Württemberg started the approval process for a new fully automated plant near Stuttgart. They had the funding. They'd picked their equipment suppliers. They'd already secured the land. 5 years later, in 2023, construction still hadn't started. The project was stuck moving through environmental review, 2 separate rounds of zoning approval, mandatory union consultation under German labor law, and grid connection sign-off from a regional utility, each one handled by a different office, on its own separate timeline. None of them running at the same time. That's not Germany failing at engineering. That's a governance system built around labor protections and environmental oversight, designed decades before anyone imagined a factory with 0 workers running at 3 in the morning. China's designated manufacturing zones skip most of that entirely local approval, national certification, and construction all move simultaneously. Land to first production, 2 to 3 years. In Europe, even under good conditions, the same process runs 5 to 10 years. The gap isn't the technology, it's the calendar. So what does this actually mean for the people who used to hold these jobs? Here's where it gets uncomfortable. China's manufacturing workforce dropped from 115 million people in 2013 to below 85 million by 2025. Over 30 million jobs gone in just over a decade. And here's the part that should really stop you. Chinese exports hit record highs in early 2026. More goods are leaving the country than ever before, made by millions fewer people. Youth unemployment in Chinese cities hit 17.1% in late 2025, and several economists think the real number runs higher than that, since not everyone who stopped looking for work even gets counted. It's not that automation killed every job in the room. New ones did show up: robotics technicians, AI system trainers, people who maintain and troubleshoot equipment that used to run on human hands. China has poured more than $15 billion into retraining programs since 2020, trying to build that workforce. But retraining someone who spent 15 years on an assembly line to maintain an AI-driven production system isn't fast, and it doesn't work out cleanly for everyone caught in the middle of it. And here's the part that explains why the government cares this much. A robot doesn't get sick. It doesn't ask for a raise. It doesn't quit for a better offer down the street, and it doesn't go on strike. China spent $1.4 billion in 2023 alone just on robotics research, separate from construction costs entirely. They didn't build these factories only to cut headcount. They built them to remove an entire category of risk that comes bundled with employing people in the first place. And the pace isn't slowing down. By 2030, China's own industry ministry expects the majority of large facilities inside these designated zones to meet full lights-out certification. The next generation of plants won't just run themselves, they'll start adjusting their own production sequences based on the data they collect, without anyone telling them to. There isn't even a settled English term for that category of factory yet. So, here's where it leaves you. Would you feel okay knowing the products sitting in your house right now were built almost entirely by machines, with barely a human hand involved anywhere in the chain? Or does manufacturing only really work, only really mean something, if people are still at the center of it? Let us know what you think in the comments. And if this kind of deep dive into the technology quietly reshaping the world is something you want more of, subscribe and turn on notifications, because this is not the last one.